Remember we talked about the idea of valence electrons versus core electrons. We said valence electrons were those electrons that were involved in bonding, those that were involved in chemical reactivity. And we also looked at how to determine how many of those there are for each individual type of atom that we would find on the periodic table. Well, what I want to do is I want to come back and refresh that again. Finding the number of valence electrons is a stumbling point for a lot of students. And if you can't determine those, it becomes difficult to write Lewis structures, do formal charge, to be able to determine geometry using our Vesper model. And so what I want to do is I want to just look at 3 different elements. I'm going to look at carbon, look at iodine, and we'll look at oxygen. Again, I always like to write out oxygen because I don't want you to think that that is a 0. It is O for oxygen. Oftentimes those get confused. So what we're going to do is I'm actually going to show you a periodic table. We're going to count along on the periodic table, or it's going to be marked such that you're going to be able to see as I count what it is that I'm counting. And then determine how many valence electrons each of these atoms have. And you might say, why did you choose these 3 elements? Well, it's because we're going to continue using these 3 to write Lewis structures in the next couple videos. So you're going to see exactly, we're going to sort of march through the problem from the beginning step through the final product, which is not only just Lewis structure, but we're going to take that further even to what the geometry would be. So let's take a look at carbon first. Now I'm going to bring up a copy of the periodic table for you to use. You'll notice that it has marks on it such that you can see what I'm going to be counting. So you can follow the numbers along as I count along the periodic table. So for carbon, remember, and for any element, basically it is the outermost S and P electrons that we're worried about. So we're going to count all the electrons in the S block and all the electrons in the P block, and that's going to be the number of valence electrons. And that sounds a lot more complicated than what it is that we're going to be doing, because what we are going to be doing is just counting from the left-hand side of the periodic table over to whatever element we're trying to determine the number of valence electrons for. So for carbon, we're going to start with lithium. It's in row number 2, or period number 2 on the periodic table. We're going to start with lithium, and that's going to be 1 valence electron. Beryllium is going to be 2. Boron would be 3, and carbon would be 4. And you'll notice I count 1 electron for each spot that I move over on the periodic table. And so carbon would end up with 4 valence electrons. Next, we're going to look at the periodic table and count over for iodine. Iodine is going to be a little trickier than what we've from carbon that we just looked at, simply because there are d electrons present, and we only want to count the s and the p electrons. So for iodine, we're going to start on rubidium in row or period number 5. So rubidium would be 1, strontium would be number 2, indium would be number 3, tin would be 4, antimony would be 5, tellurium would be 6, iodine would be number 7. And so iodine would have 7 valence electrons. For oxygen, we're going to bounce back up to period number 2, or row number 2 on the periodic table. Lithium would be 1, beryllium would be 2, boron would be 3, carbon 4, nitrogen 5, oxygen would be 6. So 6 valence electrons for oxygen. So now you can see that determining the number of valence electrons is very simply just taking a look at the periodic table and counting over from the leftmost edge. We skip any d electrons and we only count s and p electrons. Now this becomes very important because, again, outermost S and P electrons, or valence electrons, are the only ones that are involved in bonding. So these are the ones that we're going to have to keep account of whenever we are determining or trying to write a Lewis structure, which is coming up in the next couple videos.